Okay. All right. So today we are going to do 06. Okay, this one. 40. Oh, what? This is March 21. Okay, we want to do March 20.
February, March 2020.
Yes. You're right. My bad. March 20. Okay, so this is one. So calculate the a rocket is launched vertically upwards. The rocket travels uniform acceleration. After 8 seconds, the rocket is okay. So 120 minus 0 divided by 8. Change in velocity over time. So I think this has to be 15 meters per second square. Okay. Then says draw a graph for rocket. Okay. So we will start from 0. And in 8 seconds, this is 6, 7, 8. 8 seconds, it had reached 120. 110, 120. Right. Okay, so I would take a line. And do it like this. Okay. Now it says use the graph to determine the height of the rocket at 8 seconds. So half times 120 times 8. Because it's area under the graph, right? So that's 480.
480
meters. Do not forget units. From time 8 to 20, the rocket rises with increasing speed but decreasing acceleration. Okay, so it means this line should be actually till here. And then it is saying to draw the line, increasing but decreasing acceleration from 8 to 20, so till 20. Okay, did it give us from time to rocket has constant speed less than 200, something less than, okay. So we got to go till something less than this 20. So it will go like this. And then it will become constant. Like this. All right. Now it says this is 3 marks. Please do let me know if you don't understand this. Now, shows an athlete.
Can you show the graph one more time?
Yes.
Okay, sir.
Okay. Now, the mass of athlete is 71 kg. Calculate the impulse applied to her as she slows down. Okay, so you have speed is 10, she slows down to 4, right? So mu was 71 times 10. mv was 71 times 4. So impulse is basically change in momentum. So 71 times 4 minus 71 times 10. So it just says magnitude, so we're just going to write magnitude. So that is 426. And the units will Newton second. Yes.
So is this part of my syllabus as well? 50541?
No, it's not. So
Okay.
just define impulse in terms of force and time. Product.
Okay.
Yes.
I got negative 426.
It's fine, but it's all right. Negative or positive don't matter. That just shows the direction. Okay.
Okay.
It's asking about the magnitude. The athlete takes this to slow down speed from this to this. Calculate the average resultant force. Now force is equal to ma, right? Force is also change in momentum of all time. So change in momentum for 5054 people, if this question comes, right? So what you do, you find the acceleration, right? So 71 mass and the acceleration was from 4 minus 10 divided by 1.2. For 606 you can do both basically. Change in momentum was minus 426 and divided by 1.22 directly. So whatever you do, the same answer will be there. So 426 divided by 1.2. This is 355 newtons, right? And you can check it from this one as well. It will be the same. All right, Khatija?
Yes, sir.
Minus 5 times, this is the same. Now calculate the force required to give a mass 71 kg in acceleration of this. So now we use F equals to ma. Now 71 kg and acceleration is this. This is 454 almost, right? 454 newtons. Pretty easy. Then comes this one. It says show the model of wind turbine, demonstrate wind energy generate electricity. There is wind, there is cross-section area. So it says the mass of air passing through the cross-section area each second is this. So mass is 7.5 kg, time is 1 second. The kinetic energy that passes through this circular area is this. So the energy kinetic is equal to 240. So it says calculate the speed. So kinetic energy formula is half times mv squared. So 240 half, mass is 7.5 and velocity is this. So let's do it. This will be 240 times 2 times, okay, no, divided by 7.5. 64 and under root answer. So velocity is 8.0 meters per second. Do not forget units. Now, kinetic energy of the air drives the generator. State the input power of air passing through the turbine blade. So power is energy upon time. So energy is 240 and the time is 1 second. So the power will be, of course, the same 240 watt this time. Then says the current in the generator is 2. The output potential difference is this. Calculate the output power. So power is voltage times current. So 11 times 2.0. So it has to be 22 watt. Calculate the efficiency. So output over input was 240, right? Multiply by 100% because it wants us to give it in percentage. So 22 divided by 240 times 100, that is 9.2%, right? Any questions? Now, it says the density of air is this. Calculate the volume of air passing through the circular area. So density is mass over volume. Mass was 7.5, density is 1.3. So this should be 5.8 meter cube. Okay. Any questions? Please let me know. Okay, then it says define the specific latent heat of fusion. specific latent heat of fusion is basically energy, which is heat required per unit mass, right? For 1 mark. The second mark should be to completely change a solid to liquid, or you could write liquid to solid without change in temperature. All right. Now, small pieces of ice, 0 degree, are added to 0.35 kg of water. The initial temperature of water is this. The temperature of water decreases to this. The water loses this first thermal energy as it cools. All the ice water melts. All the ice added to water is melts. Okay, the specific heat of fusion of ice is this. Calculate the specific heat capacity. Okay, so heat capacity's formula is Q equals to mc delta theta. The heat energy water loses was 35,000. Mass of water was 0.35. We want to find C. And the change in temperature was 24.5 minus 0. So let's do it. 35,000 divided by 0.35 divided by 24.5. So the heat capacity is 4082. Yeah. 4082 kg per Kelvin per Kelvin. Sorry. Joules per kg per Kelvin or per degree Celsius, whatever you want to write, but do write the units, please. Then you can say the mass of the water added. Now, this is very important, and that's why it's 3 marks. So we should remember that gain of heat by ice, it should be equal to the loss of heat by water. So this should be the equation, right? So the gain of heat, because it is melting, so we're going to use latent heat of fusion times mass, and it was heating. So mc delta theta, right? So latent heat of fusion of ice was 3.3 times 10 raised to 5. The mass is what we need to find. And this whole was equal to 35,000 because this was the energy lost, right? So mass would be 35,000 divided by 3.3 times 10 raised to 5. So let's try this. So this would be 0.11 kilograms. All right, let me know if you have a question. Then question number 5, complete the sentences with words that describe the main processes. A man goes for a walk on a cold day. He touches a metal gate which removes thermal energy from his hand by conduction. All right. He holds the sides of the cup containing a hot drink. His hands gain thermal energy by conduction. Well, that happens between solids, right? Some farm workers have lit a fire. The man warmed his hand by side of fire. His hands gain thermal energy by radiation. All right. Now describe in terms of particle transfer thermal energy to the metal gate after transfer from man hands, right? So you should always remember that whenever metal transfers energy, so it is done through 2 things. Vibration of particles and movement of electrons. Which electrons? Free electrons. Okay. Let me know if you have a question. Then says this car looks car on a sunny day in a hot country. Okay, so this is the way for sure. The object labeled A is placed inside the windscreen. It is used by owner of car to reduce temperature of the air inside. Ring the most suitable material for the outer space or outer surface of object A and explain your choice. It should be shiny and white. Why? Because shiny and white is a poor absorber and a good reflector. Everybody understand this? Any question? All right, pretty good. Now 6. Draw 3 more crests on the right of A. So it should be like this. Equally spaced, please. All right, it's best to use the ruler. State the name of wave process that occurs when passes point A. Oh, sorry. It should be like this, by the way. This is called diffraction. This is not in 5054. Shows the crest and the wave is moving deep to shallow. Draw an arrow to show the direction of movement of wave. So basically what you do is from deep to shallow, it bends towards the normal. So at this point, you draw a normal line, which should be 90 degrees to the surface. This is the direction of the wave, and then this will be the direction of the wave. Now, how do you know where to make the arrow? Please understand this. The movement is always 90 degrees to the wavefront. So when you draw an arrow here, this arrow should also be 90 degrees. And when you draw an arrow here, this arrow should also be 90 degrees to the movement. So you'll get the right one. Okay. Then state the name of the process that occurs, that is refraction. What do you guys say? Is it clear? All right. Now, it says complete the table. When the waves go in shallow water, their wavelength decreases. Their frequency stays same. We have already written this. You can check, from the notes. Speed decreases. Right. Now, question number 7. Now, this is very important, and please do learn this. It says on figure, draw 2 rays to locate the position of object. So the image is given. So first of all, you will pick the top of this, go through the, optical center. Just fix it a bit. So this is optical center, it goes to the optical center. Then just make a straight line like this. Okay. Now, the other ray always starts from the same point, but goes through the optical center. So focal point and then optical center, like this. Wherever these two lines, just match, this would be the top of the arrow and this will be the object. Is it clear, everybody? So the focal length in this is from C to B and C to A. AC and CB are both focal lengths. Is it clear, everybody? Any questions? All right. Now, in this one, red light enters the triangular block along with same path as the green. Draw an arrow to show red lights. So basically, this is green light, and red has less, wavelength, more wavelength. So red basically refracts less and disperses less. So it should be somewhere here, like this, and starts dispersing from the point it enters. Start from here. Then red light enters a rectangular block shown, same path as green light. Draw path of red light within the rectangular block. So you just need to make it would diffract less, and then it would also diffract less like this. Diffract less. Let me see. It should be basically some of it should be diffracting. It's not like this. That's fine. So in the it should diffract less, and then it should also be, when it comes out, they will have the same speed, so they'll go together. I think it should be this. Okay, then everybody understands this? Any question? This is green, this is red. Let me know. Okay, now going to this one. A lamp of resistance 3 ohm, line XY represents a uniform resistance of wire 6. Right. And then it says calculate the reading on the ammeter. Ammeter is the total current. So you have 3 things in series. So the resistance total would be equal to 6 plus 2 plus 3. That is, what is this? I don't know, 11 ohm. Then V is equal to IR. Voltage, total voltage is 12. Total resistance is 11. So the current will be 12 over 11. Okay, by the way, I just wanted to tell you one thing. And that is, this is 1.1 amperes. I just want to tell you that if you write the answer as 12 over 11, that would be wrong. Fractions are not allowed at all. You have to write correct unit and in decimal numbers. Please do that. Then, in this section, it says, shows a circuit, different connection resistance added. The length xy of the whole resistance is 2. Okay. And the contact is made Q where distance is this. Fine. Calculate the resistance of the circuit now. Now you have to understand something very, very clearly. This whole thing, if you look at it, this is parallel and this is in series with this. So I want to first solve the parallel one. The important thing is that right now the connection is made at this point. Before this, X and Y had a resistance of 6 ohm. Now you know that resistance is driven by length, like resistance is directly proportional to length. So we could say if 2 meters had a resistance of 6 ohms, then how much resistance would be in 0.60 meters? You got to cross multiply. 6.0 times 0.60 divided by 2. So the resistance here
1.8.
1.8. Okay, 1.8 ohms. Now it means this is 1.8 ohms and parallel to it, it is 1.5. Now it wants us to find total resistance. 4-mark question. Wow. So first of all, I would find this one. So how to do this? 1 upon R equals to 1 upon 8 plus 1 upon 5. So when you do that, 1 divided by, oh my God,
11 over 9.
Sorry?
11 over 9. For
Are
1
you
over
sure?
R.
Are you
1
sure?
over R.
Okay. 1 divided by 1.8 and for R? Okay.
For
So
R, it will
this-
be 9 over 11.
It is 0.8, right? 0.82. So
Yes, sir.
0.82 ohm is the resistance, and then this whole is 0.82. Now you have 2 and 3. You have to add them because this series. So total would be equal to 0.82 plus 2 plus 3. And 0.82 plus 2 plus 3. That is 5.82 ohms. All right, everybody could do it. Any questions, anything you did not understand, please let me know. Okay, now going to the next one. This is a gate called NAND, by the way, because this is a and there is a not in front of it, so it is called NAND. Then it is input when it is 0 switches to 1, 1 switches, this is not. Then there is a circuit like this. It says there's a truth table, and we want to know if CD was 1, 1, what would be E? So first of all, let's try this. If C and D was 1, 1, and this is AND, so 1, 1 AND would do it 1, but there's a not, so it will make it 0. So it has to be 0, right? And then if this was 1 and this was 0, it would give you 0 in AND, and not would change it to 1. So that would be 1. Then okay, so that this is also the same, because if this is 1, 0, this will be 0 and this will be 1. And then let's talk about this one. 0 and 0 will be 0, so it will change it to 1. That's one. So all of them are 1 except for the first one. So we filled first table. Now for this table there is OR. This is OR, this is AND. Okay. So now we got to check. If the answer here was 1 and 1, this means that AND can only give, like AND has a truth table. Let me show you. Let's make 2 truth tables, X and Y. So let's say A and B and C and D. Okay, this has D. So if it was 0 and 0, it would give you 0. If this was 1 and 0, it would give you 0. If this was 0 and 1, it would give you 0. And 1, 1, it would give you 1. Okay. So that's inputs for D. So for that, we can, fill it like this. So if 1 is only possible at D if both of them was 1. Right? Now this is only possible. Now OR, for OR, we also need to check. OR is A, B, and the C. So OR, when it is 0 and 0, it gives 0. When it is 0 and 1, it gives 1. When it is 1 and 0, 1. And 1 and 1, 1, 2. So we got to check. So if this was 1 and this was 0, so this means that for AND, both of them don't matter. And for one has to be 0. So I think we could write 0 and 1. That could give me the answer. For this, it should be 1 and 0. That could be the answer. And for both of them 0, it means this has to be, both of them has to be 0. Otherwise, it won't give you 0 here. That's how you will be able to do it. Is it clear? Right? Okay. Now, then going to this one, it says magnetic field of alternating current. Describe magnetic field of this alternating current. What is this? Achha, this is a flat coil of the top view. So magnetic field of alternating current keeps us switching the direction, right? So there is always magnetic field. Magnetic field will be produced due to movement of current. So that would be your first mark. And for the second mark, you will say that it keeps on changing its direction of field. This is because the current is alternating, right? So you have to write this. Now they say there is a coil and there's a pan. State what quantity is induced in the base of the pan. Of course, current will be induced. Why current will be induced? Current, you can also write voltage, by the way, EMF, whatever you want, right? Potential difference. This is because, change in flux. Well, you should remember if there is a changing magnetic flux, then in case there is another metal, it causes it to induce voltage or current. Now, the pan contains water. State and explain the effect of quantity induced in B on the temperature of water in the pan. Now, you guys need to understand something. Current causes heating. It always does, right? If the current causes heating, then temperature of water in the pan increases. All right, for the third mark, we write the base of the pan will be the hottest due to current induced in it. This is a very good question for the first time. Right. Any questions, please? Let me know. Okay. So Abdullah, Ayan, Hatija, Malak Shafa, on Zahan. Who hasn't, Hadia, who hasn't done the paper? Tell me the truth.
So I did most of it.
Alone, because I was
That's-
finding really difficult.
That's not fair.
Sir, I did it. Whole finish.
No, I couldn't
And-
solve some questions.
Me too, sir. I also finished mine.
Okay, that's fine. Okay, so it says helium-3, hydrogen-1 has a proton number 1 and nucleon number 2. Two isotopes of helium-3 and helium-4 are there. Helium-3 has proton number of 2 and nucleon number of 3. Helium-4 has nucleon number of 4. Complete the table. So in helium-3 and helium-4, the number of neutrons would be definitely different. For helium-2, the number of neutrons will be 1. For helium-2, it will be 2. Number of electrons would be 2 and 2 because proton numbers stay the same. Mass compared to neutral atom of hydrogen. So if you look at it, hydrogen has 1 mass, helium has 3 or 4. So compared to, this is going to be, 3 times. This is going to be 4 times more. Now, experiment takes place in laboratory shielding from all background radiation. A sample of radioactive material is wrapped in aluminum foil thickness of this. The detector, if ionizing, placed with 1 centimeter foil records a reading. The piece of aluminum is thickness of 5 millimeter. Placed between detector and foil, the detector reading drops to 0. State and explain any type of radiation passing through the foil. Now, first of all, what type of the radiation should be passing through the foil? Well, if I were you, I would say that gamma will not be stopped. Right. And then I would say beta will be stopped by 5 millimeter aluminum. And alpha will be stopped by both 5 millimeter and 0.1 millimeter, because alpha cannot pass paper. How would it pass aluminum? That's crazy, right? So here we go.
Okay.
And finish. Yes, Hadi.
For the table above, why did you write 3 and 4? It is
Because no, if hydrogen is 1, helium-3 means 3 mass, 2 protons, and helium-4 means 4 mass, 2 protons. If I want to compare hydrogen with this, how many times it is heavier?
Twice.
3 times. 3 times, Hadia. So 3 hydrogens would make up this, right? Something like
Yeah.
that. And how many times is this? 4 times.
4.
So that's what I've written. All right. Then anybody else wants to, ask anything you did not understand?
I am
So the
completely
papers aren't this
confused.
difficult, right?
Okay, one by one. Malak first. Yes, Malak.
Sir, with this table, how did you get all of those numbers? I'm so confused. How
Okay.
did you get the electrons?
Okay. Well, let me write it down for you. So first of all, let's talk about hydrogen. So it said hydrogen 1 has a proton number 1 and nucleon number 1. What does that mean? That hydrogen has 1 mass, 1 proton, right? Then it says 2 isotopes of helium, helium-3 and helium-4. Helium-3 has 2 protons and nucleon number of 3. So 3 and 2. Agreed? That is helium. And helium-4 has 4 nucleon number, but they are isotopes. So isotopes have the same proton number. Agreed? Do you understand, Malak, up till now?
Yes, sir.
Now, for number of neutrons, what you do? You have to do nucleon number minus proton number. So 3 minus 2, 1. 4 minus 2, 2. Do you understand?
Yes.
Then number of electrons. Number of electrons should be the same. If it's a neutral atom, then it should be same as the number of protons. So it has 2 protons, so 2 electrons, 2 protons, 2 electrons. Got it?
Yes, sir. Understood. Thank you.
And now compared to this is 3 times and this is 4 times heavier. So that's why this table is split. Okay, next. Yes, Khatija.
So I was just asking that the IGCSE papers are usually more difficult than the ones we have in
Yes,
as
they
your
are.
paper.
Yes. Yeah.
Okay.
You can see, these tables never come, these sort of questions. They're difficult. So it's better.
Yeah, sir, because I find these much more difficult than the ones you done in school. So I was like,
Yeah, so your school papers are so easy. Don't worry about them. All right. And also in your school paper, the difference is that you will also have a choice. There will be 12 questions. You still have to do 11 questions, but you will have choice in last 3 questions. You can choose to do any 2. Unfortunately, these
so there's
people,
13
yeah.
questions.
So no, you will have total of 12. You will have 12 questions. You have to do 11. It's the same as IGCSE, but 1 question will be a choice question. So like in section B, you will have to choose 2 of the 3. Okay. So unfortunately, these IGCSE people, they don't have that privilege. Okay.
Right.
Right. So yes, anything else? Anything else? Abdullah, Ayan.
Right.
So who's really happy about the score? Yes, Hadia.